Working with arrays and processing is how we're able to manage larger collections or groups of objects. So an array is a very specific data type inside of processing, and it's also used in just about every other programming language as a way to store a group of similar objects. So if we have a bunch of numbers we want to keep track of, we can put them into an array. If we want to have a bunch of names we're keeping track of, we put them into an array. If we want to have a bunch of objects we're keeping track of, we put them into an array. Because once it has all of those objects in that array, then we are able to do something with them. So we can sort them, we can organize them, we can question their properties, we can search through it to look for a specific value. So arrays are a really powerful way to keep track of things inside of processing. So there's a couple of logistics that we have to adhere to when we are setting up arrays. So if I'm going to just have a basic array that is holding a bunch of integers or numbers in it, now I can set up and create a variable to store it. Now we'll notice this is a little bit different than how we've done variables in the past. In the past, we would say the data type and the name, but here I also have a set of square braces. These square braces indicate that this is going to be an array. So that's our first clue that that is happening. Now, to populate this array, what we can do is I can say int. So int, the name of the array, is going to be equal to new int, and I'm specifying what is going to go in this array. And now I will declare how many integers, numbers, are going to be inside of this array. So one thing that processing needs is it needs to know how many spaces to reserve for information in that array. So it wants to know how many slots to hold. So if we think of an array, if we use a sports stadium analogy, so if we look at a sports stadium, that stadium may have 60,000 seats. So that means we know that there's 60,000 objects in that array. Each one is sequentially numbered, so we can find and access that particular seat, find out which person is sitting in that seat during that game, because we can then look up, is it a season ticket holder, who is it, or look up who purchased that ticket. So we're able to find out all of that information. Now each seat also has other information. Is it an expensive seat, a cheap seat? Is it an aisle seat? Is it close to the field? Is it high up? So it also may have additional properties with it if it's more than just a simple number. But much like the number of seats in the stadium is fixed, the number of objects in an array is fixed at the time we create it. There are some little opportunities we have down the road where we can modify the length of this array, so we can make the array longer or shorter if we want, using our array methods. But the standard way, and the way that we're going to be working with arrays in the coming projects, we are going to set up our array as a fixed number of objects or spots, and then populate those spots with whatever we want to put into it. So currently, I have an array that is 3 spaces long. Each space is going to hold an integer. Now, to put an integer into that array to populate it, what I need to do to put something into it is I need to specify the name of the array and then what position I want to put it in. Now you'll notice I said 0, and an important part of arrays is they start identifying the position of objects in the array by counting from 0. So the first object in this array is at position 0. The next object in the array is going to be at position 1. The final object in this array of 3 objects is going to be at position 2. 0, 1, 2 corresponds to the 3 positions of objects inside of this array. To see what is inside my array, I am just going to put a command. Actually, I can just do it in setup right here. And then I will just tell it to print out ints. So ints is my array of ints. Now if I run this, I will see that it printed it out in the console down there at the bottom. At space 0 is 12, at space 1 is 56, at space 2 is 8. Now we're going to try this again. And I'm going to make an array of strings. Now my array of strings, that means these are collections of letters. So I could use names, I could use verbs, I could use anything that I want to put into it. And we'll just go after it and go strings is equal to new. Now I have to specify again what kind of item is going to go into it. This time I will put 4 strings in my array. And then I can say strings at position 0 is going to be equal to, I'll just put my name. Strings at position 1 can be equal to, I'll just say tiger. Strings at position. Now, I don't have to populate my array in order. I can populate it in whatever order I want because I'm specifying what the position and then value will be. Now if I print this out, so if I run the sketch, we can see that it prints out the 4 values that are part of that array. But notice I did 0, 1, 3, 2, so John Tiger red ball. But if we look here, John Tiger ball red. So it doesn't matter the order in which we populate our array. So we can now change it if I'm so inclined. So I could say strings at 0. I could set that equal to Fred. And now if I run it, I'll see that I have changed. Oh, if I printed it out again, then I get to see that I changed the value. So we can see how the value has changed inside that array. Common error that you will sometimes see is if you request something out of bounds. So if I change the 2 to a 3, so 0, 1, 3, thinking, oh, I have 3 objects, I should put a 3 there. But we have to remember, we always start counting at 0. So 0, 1, 2. There is no object at the 3rd position. So when I try and run this, I'm going to get an array index out of bounds exception. And it's telling me that I tried to access something that I'm beyond what it is. Now if I change this to 4, then that would work because it's 0, 1, 2, 3 are the 4 positions. So now that 3 is no longer out of bounds. And if I look at the array, we'll see that it populated it 12, 56. I never specified a value for the object at position 2, so it defaulted it to 0. And then we have the object at position 3, which is my 8. One thing that processing does is it will autofill it so you don't run into errors of having nothing there. When the program is looking for something, it will put in at least a base object type so it doesn't freak out. Other programming languages tend not to be as generous. So when you're working with arrays, it does become important that you make sure you're always populating all the values that you're expecting to use. It's not going to hold your hand along the way. It's one of the good parts about processing is it tries to eliminate some things that are common errors so that you can just go ahead and make stuff instead of worrying about adhering to having to always do things in the strictest possible way. 1,000 objects, I probably don't want to type int 0, int 1, int 2, int 3, int 4, up to 1,000. At that point, my fingers will be tired, my program will be illegible, and I'll probably cry. So we don't want to go that road. That's not how we want to go about populating it with that. But if I wanted to put 10, 50, or 100 random numbers into an array, I could do that very easily. And the way that we can go about doing that is we can populate it using a loop. So if we remember, we looked at loops last session a little bit. We're going to come back and revisit those now. So I am going to have an array filled with float numbers, and it will be called random numbers. So I'm just going to move this up on screen here. Random numbers, it's going to be equal to new. And now declared we're putting floats into it, and I can specify how many. In this first go around, I think I'll just start out with a even 10, and then we will find that we can very easily add to this as we go. So what we can do with this is where using a loop comes in handy. So for this, I'm going to, that's bad language. For this, I'm going to use a for loop. In this example, I'm going to use a for loop would be a better way of phrasing it. And when we are creating loops, we start out, we declare what is our iterator that we are going to use, or our counter. And then we are going to declare how many times we are going to go through this. So while I is less than 10, we're going to find out we can access that 10 value in an even better manner in a little bit. And then I is going to increase by 1 each time we go through our loop. And that is what the plus plus is equal to. Plus plus is the shorthand. So that's the same as saying plus equals 1, which is the same as saying I is equal to I plus 1. So anytime we're just adding a single amount or subtracting a single number from something, we just use plus plus or minus minus. That's the easier way of writing that out. Anytime you put in a curly brace, type your curly brace, hit return twice, put in your closing curly brace, then go back up a line to start typing your code. That will prevent you from forgetting that closing curly brace. With my for loop set and ready to go, what I can do is say random numbers at position I. You'll notice the convenience of I starts counting at 0. My array starts identifying the position of items in the array at position 0. So we're able to make that work. And now we can put in a random number, say random number out of 100. When it's all done, print line numbers. Now if I look down below in my console, I will see that it printed out 10 random numbers between 0 and 100, and they are all floats. To make this random collection of numbers more than 10, so if I said it's 100, now I can type in 100 here. I also have to remember to add an extra 0 down here. But a better way of doing it is I can access the length property of my array. So one feature that arrays have is they have a property of how many slots do they have in them. Using our stadium analogy, how many seats are in the stadium? So we know that this array has a length, and that length corresponds to how many seats we reserved in it. This way, if I go from 100, it works. Now I got all 100 numbers, but I can also go to 1,000, and it works. But I don't have to remember to go back into my for loop and retype in how many objects are in that array. So that's a better way of doing it. That's an optimization that we can make to better manage our array. And we will be looking at even better ways to optimize it in the coming sessions. Converting our previous box objects into using an array is the same as what we did previously with working with our arrays. So we have to define the type of object that's going to go into it, give that object array a name, and then populate it. So it's going to be very similar. So instead of box B1, box B2, box B3, I'm going to just comment that out because I'm not using those now. And I will say box again because I'm going to create an array of box. And that array I will just call boxes. Now we can see there's B1, B2, and B3. I'm going to just comment those out because, again, we're not going to be using those. Now boxes is going to be a new array filled with the box object, and I will just put an even 10 objects in it. Now if we try and run our code, of course, we'll get errors because the draw method is looking for telling B1, B2, and B3 to update. We're going to access those differently. Actually, to make it the same as what was there, I'm going to just start out with 3, but we'll find we can very easily change that number and make it bigger or smaller as we want to go. So if we were doing it with 3, we could say boxes 0 is equal to, and this is where it gets a little bit different. This is where we have to add our objects a little bit differently, where we then say new box, and then I need to specify how I want to go about doing it. Now with 3 objects in the array, again, we could do this very easily. Actually, I'm going to recycle some of this, showing that it really is, it's the same but different. And then our final object in the array will be equal to, and we'll go grab that third one. So it's the same kind of thing. Under the draw, this is where everything is going to get a whole lot nicer because we're not going to have to do all of that, but instead use a for loop. Because to cycle through all of these, I could say boxes. So we could change this one if we just left this here and said boxes 0 update, and we'll Just do a little copy paste action to speed that up. So if we look at what we have now, we have an array of 3 boxes. It's the same 3 boxes we had before because they get their same 3 properties. Then we tell the item at position 0 in my boxes array to update. So I don't even have to now know, what is it B1, is it B2, or B3. I'm just saying I want the object in that seat in my array to update. Now if I run and get one going. And again, if we have 2 objects, 3 objects, 4 objects in our array, we can manually go through and do it this way. But if we have 10 objects or 100 objects or 1,000 objects in our array, then this is not going to be as advantageous of a way to work. This is where we instead will want to use our for loop. So we start out int I is equal to 0, then I is less than boxes dot length, then I plus plus. Open curly brace, return twice, close curly brace, up arrow once. Now I'm ready to do what I need to do. And now for this, it's boxes. And now the one I want to update, I'll say boxes I dot update. Boxes I dot check bounds. And boxes I dot display. Now we don't need that anymore. So what we'll see is by putting these objects into the array, we're able to now loop through those objects much more efficiently, so I don't have to specify each one hard coding its name or hard coding its position in the array. I can just use this for loop to cycle through it. And now that gives me 3. If I add a 0 in, well, so I added a 0 in, and I forgot that I only populated my array with 3 objects. So then when it tried to get to the object in the 4th slot, it gave me null pointer exception, meaning it tried to access something that does not exist. If my array was populated with ints, it would have auto-populated it with zeros, so it wouldn't have mattered. But because it's with objects and the objects have to have their constructor called, we need to do something else. So if I want to populate my array, I need to have a new strategy. So the strategy I want to use is to use a for loop. So now I get to type in another for loop. Now, what you may find is if you want to copy paste that because it's easier for you to do it that way, that is totally wonderful. Just make sure you change all the appropriate items that need to be changed. But you'll notice that when we're typing in a for loop, a lot of it is redundant. There are some code editor tools that we can use, not for processing, but for other languages. When I type in for, it auto-populates it with the core structure of a loop, like what you see right here, except it hasn't defined what box's length is. It leaves that part for you to put in what you want, and then that makes it a little bit easier. So now if I say boxes I is equal to a new box, and now I can define what I want that box to be. If I just leave it as the generic random one, so I don't even bother passing in any constructor values, I can do that. And now if I run it, we'll see there's 30 objects that showed up on screen. Try again. the fun part about this is now if I change this to 50, it still works. So you can just keep changing it, and you can see how they all have their own independent x, y, and speed x and speed y, which is why they're all moving independently. It's also possible to very quickly find how the computer can start to slow down if you end up with too many objects moving on screen. To finish cleaning this up, I am going to just remove all the references to box B1, 2, and 3 just so we can see how much easier and better this becomes. So now if I look at what's there, the entire program fits on one screen. It runs with no errors. So I have my array of boxes, construct that array, declaring how many go in it, populate that array with a for loop, and then use a for loop to cycle through the individual objects in my array, calling their methods. So the reality is this is completely the same as what we did. It just allows us to manage a much larger number of objects as we work on our projects.